Hi and welcome to the session. In this session, we are going to discuss about the topic Cathodic protection from Unit 6 Corrosion Science. The learning outcome from this session will be students should be able to explain protection of metal by sacrificial anode method. Students should be able to explain protection of metal by impressed current method. Now, what is cathodic protection? Cathodic protection is the method of metallic protection from the corrosion in which the metal which is to be protected is forced to behave as a cathode. Now, if you see the corrosion process, in corrosion process, the corrosion occurs at the anodic metal or the metallic part, while cathodic part of the metal or cathodic metal will not be affected by the corrosion. And hence, if we want to protect certain part of metal or the metallic structure, then if that metallic structure or the metallic part acts as a cathode, then in that case the cathodic part will not get corroded and it will be protected from the corrosion. And this principle is used in the cathodic protection. So here, in case of cathodic protection, the metal or the metallic part to be protected is forced to behave as a cathode. The cathodic protection can be achieved by two methods. First is the sacrificial anode method and second is the impressed current method. In case of sacrificial anode method, the metallic structure or the part of metal which is to be protected is connected to another metal having higher position in the galvanic series by an insulated wire. Now here we will discuss about how the metal is protected with the help of a sacrificial anode method. Suppose this is the underground pipeline and we need to protect this underground pipeline from the corrosion. Now here, if we want to protect this by sacrificial anode method, then this pipeline should act as a cathode. It should be made as a cathode, and that can be achieved by connecting this pipeline to a metal having higher position in the galvanic series by a insulated wire. So here in this case, the metal which will be used as the anode will be zinc, magnesium or aluminum. As this metal is having higher position in the galvanic series, it will act as the anode, while this metal pipeline will act as a cathode, and corrosion occurs at the anode while cathodic metallic structure will be prevented from the corrosion. The anodic metal is always covered with the backfill. In case of sacrificial anode method, backfill is made up of NaCl coal in order to make good contact with the soil, good electrical contact with the soil. So in case of sacrificial anode method, the metals like zinc, magnesium, aluminum are used as a anode and they get corroded for protection of metallic structure. Hence the method is called as a sacrificial anode method. The sacrificial anode is always placed in the backfill made up of coal and NaCl to increase the electrical contact with the soil. The applications of sacrificial anode method are: it is used to protect the ship hull, buried pipelines, buried cable, hot water tanks from the corrosion. Now we will see impressed current method. In case of a impressed current method, the metallic structure to be protected is externally connected to the negative terminal of the DC battery, and the current is applied with the help of this DC battery either to nullify the corrosion current or reverse the corrosion current, and the method is called as a impressed current method. In case of impressed current method, the metallic structure is connected to the negative terminal of the DC battery and is made as a cathode by applying an equal and opposite current to nullify the corrosion current. The positive end of the DC battery is connected to the insoluble anode like graphite, stainless steel, and this anode is kept in the backfill composed of gypsum or coke bridge. Here we will discuss about the impressed current method with the help of a diagram. Suppose this is the metallic structure we want to protect from the corrosion. This is the underground pipeline, and this underground pipeline is made as a cathode by connecting this pipeline to the negative terminal of the DC battery, while positive terminal of the DC battery is connected to a insoluble anode. Anode is always covered by the backfill made up of gypsum or coke bridge. Here the underground pipeline will act as a cathode and will be protected from the corrosion. Now, applications of impressed current method. So impressed current method is used to protect the buried water pipeline or gas pipeline, open water box coolers, water tanks, condenser, transmission line towers, laid up ships, marine pipes or marine piers, etc. Limitations of cathodic protection. The cathodic protection may lead to the high capital investment and maintenance cost. It leads to the stray current. Now this stray current, which is generated due to the cathodic protection, may lead to the corrosion of nearby metallic articles, nearby metallic structures. Also, in case of cathodic protection, the problems associated with hydrogen evolution or oxygen absorption may increase. As we know that in case of a corrosion, the corrosion occurs at anode, while hydrogen evolution or oxygen absorption takes place at the cathode, and hence there may be certain problems which may arise due to the hydrogen evolution or oxygen absorption at the cathodic end or the cathodic metal. So in summary, we have discussed about definition of cathodic protection, then sacrificial anode method, applications of sacrificial anode method, impressed current method, applications of impressed current method, and limitations of cathodic protection. Thank you for watching this session.